India wants to build a 60-kilometer wall across the sea, but the final gap is the most dangerous part of this project. The site sits inside Gujarat's Gulf of Khambhat, where the tide can raise the water by around 11 meters. Engineers could begin from both sides and slowly push the wall farther into the Gulf, but as the opening shrinks, the sea gets less room to move. The tidal current speeds up and attacks the unfinished section exactly when crews need to close it. That problem keeps this project trapped for nearly 50 years. But now, India is turning to Dutch engineers for help. They've pulled off something similar before. In 1932, they completed the 32-kilometer Afsluitdijk and closed off an entire arm of the North Sea, a job that had once seemed almost impossible. So what could possibly justify blocking off part of the Arabian Sea, and how will engineers close those final meters without the Gulf tearing their work apart?
Well, the region sits on the western side of the Gulf. Saurashtra is a dry peninsula stretching into the Arabian Sea. Farmers across this part of Gujarat still depend heavily on monsoon rain and groundwater. When the rains arrive late or don't bring enough water, pumps pull more from underground. Wells then have to reach deeper as the water table falls. Meanwhile, the Mahi and Sabarmati rivers flow into the Gulf of Khambhat. The Dadar brings more fresh water into the same area. Once that runoff reaches the Gulf, it mixes with salt water. Kalpasar would catch part of it first. The current design could store around 7,807 million cubic meters of water. That supply could support irrigation across nearly 1 million hectares in 9 Saurashtra districts. Earlier plans also involved the Narmada. The revised alignment now keeps its estuary outside the reservoir. So that's why Gujarat wants the project. Now we need to look at what engineers actually plan to stretch across the Gulf. Starting near Kardez on the Bhavnagar side, the western section would run for 19.83 kilometers. The dike would then continue for 26.7 kilometers through the Gulf of Khambhat. After reaching the eastern side, another 13.6-kilometer section would carry it toward Paniyadra in Bharuch. Together, those sections create the full 60.13-kilometer alignment. So the entire structure wouldn't sit in open water. The landward embankments make up more its total length. And picture a broad sea dike here, rather than a narrow concrete wall. Its crest would rise around 14.5 meters above mean sea level. Along the top, planners want a transport corridor roughly 130 meters wide. That leaves room for a 16-lane roadway and 4 railway tracks. Large flood regulators would pass through the dike as well. Their gates could release heavy river flow and stop the reservoir from rising too far during the monsoon. But all that material, traffic, and water pressure would eventually rest on the seabed beneath it.
And that's exactly where engineers had to look next. Back in 1988 and 1989, a reconnaissance study said engineers could close the Gulf, but only if the seabed could support the structure. So survey vessels began crossing the proposed route. Sonar mapped the depth and shape of the Gulf floor, while the National Institute of Ocean Technology supervised earlier bathymetric and marine surveys. Crews also drilled boreholes and pulled sediment samples from below the water. These samples show where soft marine deposits sit and where stronger layers begin. They can also reveal fault zones that may move during an earthquake. Right now, the National Center for Coastal Research in Chennai is helping finalize the detailed project report. And foundation strength matters here. If the dike squeezes soft sediment unevenly, one section could sink farther than the next. That movement could crack the road above or disturb the flood regulators. Engineers may remove the weakest material with dredgers. Ground improvement could strengthen other sections, while a wider base would spread the weight across more of the seabed. Once they prepare that foundation, construction could begin from Kardej and Paniyadra. Trucks would carry material out from both shores. Earlier official studies also proposed temporary work islands inside the Gulf. Barges could deliver rock and sand to those offshore points, giving crews more places to build from.
Rockfill would create heavy tows along the bottom and stop the embankment from spreading outward. Workers would place a sand-filled core between them. Large armor stones would cover the exposed slopes and absorb the waves. Crews would raise the dike in stages instead of adding its full weight at once. Between stages, they could watch the seabed compress and correct any uneven movement before building the road and rail corridor. Concrete regulator structures would leave controlled openings for water to pass through. The final DPR may still change this sequence, especially beneath the offshore section, but every version eventually reaches the same problem. As the separate sections move toward each other, the tide gets pushed through one shrinking gap, and the Gulf of Khambhat makes that shrinking gap especially dangerous. Its southern mouth opens widely toward the Arabian Sea, then the Gulf narrows as it reaches farther north. That funnel shape forces incoming water upward, creating tides that can rise and fall by around 11 meters. As builders narrow the opening, the same tidal flow has less space to pass through. The water speeds up and starts pulling sediment away from the unfinished dike. If that scour reaches beneath the rock toes, it could weaken the base exactly where crews need it most. Workers would have to place heavy armor rock around the closing section. They'd also need to time the work around short periods when the tide slows. Before sealing the last opening, engineers would need the flood regulators ready. Those gates could give the moving water a controlled route through the dike. The structure would still face storm surges from Arabian Sea cyclones after completion. Earthquakes beneath Gujarat would send another kind of force through the long embankment. That final gap helps explain why Kalpasar spent decades in engineering studies. And closing it wouldn't instantly produce a freshwater lake. At first, the new reservoir would still contain Gulf of Khambhat saltwater. Runoff from the Mahi and Sabarmati would slowly dilute it, with the Dadar adding more freshwater. Engineers could open the regulators to release saltier water toward the Arabian Sea, while keeping the reservoir at a safe level. During a heavy monsoon, those gates would serve another purpose. They'd discharge excess river flow before it pushed the reservoir too high against the dike. Silt creates a long-term issue as well. River sediment could settle inside the reservoir and gradually reduce its storage capacity. Then there's water quality. Industrial discharge already affects sections of the Sabarmati and Mahi. Upstream pollution controls and treatment systems would need to improve before farms or drinking water networks could safely use the stored water. And the revised layout keeps the Narmada estuary outside this reservoir. Once engineers make that water system work, the top of the dike becomes a completely different megaproject. That second megaproject begins with the 130-meter wide strip running along the dike's crest. Current plans leave enough room for 16 road lanes between the Bhavnagar and Bharuch sides. 4 railway tracks would share the same crossing. Drivers who currently travel roughly 240 kilometers around the Gulf could cross it in about 60. All that traffic would keep pressing down on an embankment built over marine sediment. Waves would hit the Gulf-facing slope, while the reservoir would push against the structure from behind. Engineers would need expansion joints along the transport corridor. Settlement sensors could track whether one section sinks faster than the next. The project's energy plan has changed as well. Older designs included a 5,880 megawatt tidal power station, but planners later removed it from the main proposal. The 2026 filing now describes a wind and solar system producing around 2,500 million electricity units each year. That works out to roughly 2.5 billion kilowatt hours. Still, the most important technology may come from more than 6,000 kilometers away. In the Netherlands, Dutch crews started the Zuiderzee works in 1920. Their biggest structure became the 32-kilometer Afsluitdijk. On May 28, 1932, workers closed its final opening at a place called Vlieter. That separated the Waddenzee from the water that became the IJsselmeer. Sluices inside the dike allow fresh water to escape when levels rise. Closed gates keep seawater from flowing back in. In May 2026, Narendra Modi and Dutch Prime Minister Rob Jetten visited the Afsluitdijk together. India's Ministry of Jal Shakti then signed a letter of intent with the Dutch Ministry of Infrastructure and Water Management for technical cooperation on Kalpasar. Dutch engineers can help model how the current will behave as the final gap narrows. Their experience could also guide scour protection and the closure operation itself. As of right now, construction on the main dike hasn't started. The National Center for Coastal Research is still helping complete the detailed project report. On May 21st, Gujarat submitted a fresh application to begin detailed environmental studies. The updated cost has reached roughly $14 billion. Planning documents suggest construction could begin in May 2028 and finish around late 2035, assuming every clearance arrives on schedule. If engineers finally solve the closure, Gujarat could transform part of the Arabian Sea into one of the world's largest coastal freshwater reservoirs. And if you want to see why India turned to Dutch engineers, you need to watch this video on our channel, How the Netherlands Keeps the Ocean Out. Also, make sure to subscribe for more insane construction and the hidden engineering behind the world's biggest mega builds.